So we've just spent some time talking about how to represent negative numbers with signed number representations. We talked about sign magnitude, diminished radix complement, and radix complement. Sorry, diminished radix complement and radix complement. And although sign magnitude seemed most intuitive to us humans, radix complement actually turns out to be very easy for computers to understand because it allows for adding and subtracting of both positive and negative numbers using the same hardware. So this topic, this lecture I should say, is going to talk to you about how do we add and subtract both unsigned and signed numbers. So unsigned and signed numbers. Okay, so we're going to start with unsigned numbers because we've already looked at that a bit so far. So unsigned addition. With unsigned addition, you need to start worrying about a condition known as overflow. And what is overflow? Well, this is when you are adding two numbers and the result of that addition is larger than what you can represent with the number of bits that you have. So for example, let's say we have a 4-bit addition and you want to add the numbers 10 plus 10. Alright, so in unsigned binary, the number 10 in 4 bits is just 10, and the number 10 is just 10, and we're going to go ahead and add these. We're going to get a 0, 1, carry the 1, 1, 0, carry the 1. Alright, so look at that. Our result is the number 6. Is the number 6 what 10 plus 10 is? No, the number 20 is. So the carry that we got indicates that we had overflow. So when you're doing unsigned addition, if you get a carry bit, that means that your result is wrong. The result is incorrect. You got an overflow, meaning you could not represent the sum of these two digits with only 4-bit numbers. Okay, so now let's look at 4-bit subtraction with unsigned addition, with unsigned numbers. So when you're doing unsigned subtraction, which is kind of weird because you kind of have to use negative numbers to be able to subtract. But anyway, if we're doing unsigned subtraction, we're looking for a condition called underflow. And underflow is the case where you're going to end up with a negative number and you can't represent that in unsigned world. So let's see what that does. Let's say we wanted to do the operation of 3 minus 10. Alright, so here's the number 3 in unsigned binary, and here's the number 10 in unsigned binary. Alright, in order to do this subtraction operation, we need to change the number 10 into diminished radix complement. So we're going to have the number 3, and then we're going to subtract 10, so it's going to be copy down until you get to the first one, and then flip. 1, 1, 0. Sorry, I forgot to flip. 0. Alright, now we do the addition. We can add just an extra 0 here, but we only care about the 4 bits. We're going to end up with 1, 0, carry the 1, 0, carry the 1, 1. Okay, so look at the answer we got. We did not get a carry, and we got the number 9. Is 3 minus 10 the number 9? No, 3 minus 10 is the number -7, but we can't represent -7 with unsigned binary. So you get underflow occurs when you get no carry when subtracting two unsigned numbers. Alright, so let's just summarize this with the table in the textbook. Here you can see this is showing the overflow in unsigned binary addition, which means here we have the numbers 9 plus 3, and guess what? 9 plus 3 equals 12. There's no carry, no overflow. We can easily represent the number 12 in unsigned binary. But now we have the number of, what's this number? This is 11 plus 7. 11 plus 7 should give us the number 18. Well, guess what? We get the number 2. This is not valid. And we know that because we generated a carry. So the carry tells us that our sum is not valid. So an overflow is indicated when you add two unsigned numbers and you get a carry. Now, underflow is indicated when you subtract two unsigned numbers and you don't get a carry. So like we just did, a subtraction operation. Here we have 9 minus 3. You change the number 3 into 2's complement, which is what this number is. Then you do the addition and you end up with 6. Guess what? 9 minus 3 is 6. This is correct, and we know it's correct because we generated a carry. So it's just the opposite from the overflow condition. Here a carry means it's good, whereas in overflow a carry means it's bad. So here we go. Now we're doing 7 minus the number 12. 7, and here's the number 12 in 2's complement. We get the number 11. 7 minus 12 is not 11. So here, no carry means that, look, you got a wrong answer. So it's very important to recognize how you can tell if the result of your addition or subtraction is valid or not. And here we just did the case for unsigned arithmetic, and in the next video we'll look at signed arithmetic.